So anyway, I'd like to get started with our first presenters. Nathalia, what's your last name? So Nathalie Barrios and Ali Boolani. So Nathalie is a McNair Scholar from Stratford, Connecticut, pursuing a dual degree in psychology and mathematics at Clarkson University. Nathalie's been doing research in Dr. Boolani's lab since 2020 and has other research experience on topics including aquatic invasive species, assessing program evaluations, and analyzing emotional and motivational responses to witnessing prejudice. Nathalie aspires to continue her education by attending graduate school to obtain her PH.D. Congratulations. To pursue a career in research upon graduating this spring. Ali is a multidisciplinary trained scientist and a really nice guy. He seeks to create artificial intelligence to prescriber personalized interventions to modify feelings of energy and fatigue. He's interested in finding effective ways to identify subjective and objective measures of energy and fatigue using a combination of eye tracking, virtual reality, voice, sensors, and computer vision. Further, he hopes to identify and optimize interventions that modify feelings of energy fatigue through identifying inter and intra-individual differences in intervention responses and understanding the unique and overlapping biological correlates of energy and fatigue. That's a lot. Sorry. Anyway, so without further ado, I'd like to give the floor to Nathalie and Ali, and let's get them started. Okay, so thank you.
Thank you. Let's just see if this works. Oh, it does. Good. Okay. Nathalie, I will let you go ahead and start. And, just the play button. Mm-hmm.
Hello, so I'm Nathalie, and today we will be presenting on using machine learning to identify feelings of energy and fatigue. So for our objectives today, we're going to be talking about why we care about fatigue and about why we should too. Until recently, researchers have used energy and fatigue on a bipolar continuum rather than two distinct unipolar groups. Therefore, we will be talking about how we know energy and fatigue are different. But we will also be talking about machine learning, deep learning, and artificial intelligence, and how we can use it to individualize interventions and detect energy and fatigue. Lastly, we will be talking about what's next and the big picture on technology and energy and fatigue. Okay, so why we care about fatigue and why you should too. Well, there have been a few disparities in fatigue and energy. First being patients with multiple sclerosis and Parkinson's disease. Patients with multiple sclerosis and Parkinson's disease have been reported to feel dopaminergic fatigue. However, as we are seeing in healthy populations, changes in dopamine have been associated with changes in energy. Therefore, these patients could actually be feeling low energy instead, which could impact the treatments that are being used for them. Second, for patients with cancer, did you know that 70% of patients with cancer report feeling fatigue? Yes. However, in researchers from University of California in San Francisco have found that half of patients report low energy and the other half of patients report fatigue when energy and fatigue are measured as two distinct moods. Third, patients with chronic fatigue syndrome. Chronic fatigue syndrome is hard to diagnose, and that's because it's been hard to identify the biomarkers for chronic fatigue syndrome. Therefore, it could be because we have been measuring fatigue wrong. In about 68,000 patients, 14% have been diagnosed with long-haul COVID, and we don't know much about COVID. However, there have been reports of long-haul fatigue
and since it's new, it's very important that we understand it. Racial disparities, African Americans and Hispanics who live primarily in white areas have reported higher fatigue. No, I apologize. Low energy. However, the disparities disappear once we look at communities that are higher in African Americans and Hispanic populations. For gender disparities, wherever we look at, women tend to have lower energy and higher fatigue than men do. Fatigue and energy-related declines in performance have been associated with increased risk for injuries and increased risk for falls, which we will be talking about later in this presentation. So how do we know that energy and fatigue are different moods? Well, we have looked at biological differences in responses to various interventions, including group exercise, various exercise types, and sitting desks versus standing desks, and intermittent walking. Lastly, we have also seen an influence of energy and fatigue on various movements. So as I said before, until recently, researchers have looked at energy and fatigue on a bipolar continuum rather than two distinct moods. However, in an article by Brian Loy and colleagues, they have proposed the idea that energy and fatigue are individual and separate, but related psychological states. They define energy as an individual's potential to perform mental and physical energy, where synonyms include vigor, vitality, full of pep, and lively. And fatigue is defined as subjective perceptions of reduced mental or physical capacity. Synonyms include exhausted, sluggish, weary, tired, and feeling worn out. So biological correlates of energy and fatigue. So I said before, there's been evidence from psychopharmacology and genetics showing that changes in dopamine lead to changes in energy. Annexin A1 has been also associated with changes in energy, where declines in feelings of energy have been associated with an increase of annexin A1. Peripheral mitochondrial function has also been associated with changes in energy due to ATP production by skeletal muscle mitochondria. And then normalized resting metabolic rate has also been associated with energy, and metabolic gut microbiomes has been correlated to trait physical energy. For fatigue, brain serotonin has been found to be associated more with fatigue rather than energy. For histamine, in a double-blind placebo-controlled study, it has been found that by using the histamine antagonist doxepin, individuals reported increased fatigue. Yeah, individuals reported increased fatigue compared to the placebo, and energy has been similar with both the placebo and doxepin measures. Inflammatory cytokines such as TNF-alpha has also been associated with fatigue, and inflammatory gut microbiomes have been correlated with mental fatigue. So in a study of 27 participants participated in a community aquatic exercise program where they completed baseline surveys assessing their health status, their trait, mental, physical energy, and fatigue, and their sleep quality. They also performed functional assessments, which I will talk about a little bit later. and they also collected on random days once a week for 48 weeks their mood and their state, mental, physical energy, and fatigue before and after exercise. All subjects reported an increase in physical energy, and 45% of participants reported increases in physical fatigue. 36 participants reported an increase in mental fatigue. In a study of 67 participants, participants have filled out a mood survey for 14 days or more for completing physical activity. Physical activity have been classified using 4 ontological dimensions. These dimensions include individual, I, me, encounter, I, you, team, I, society, and nature, I, nature. Individuals who completed multiple exercise types have been classified as I multiple. As you can see here, for fatigue, there have been no changes for fatigue for the exercise types compared to those who didn't do exercise, but for vigor, there was differences in exercise types compared to those who did not do exercise. Okay. In the study of 30 individuals, 30 participants did 3 interventions. There was sitting, standing on desks, and the third one would be completing mental work for 26 minutes, followed by a 2-minute walk. They did this for 3 times, and they completed cognitive tasks for about 26 minutes. As you can see here, for physical energy, from time 1 to time 3, all groups have decreased in physical energy. Unlike physical fatigue, there were some groups that showed an increase in physical fatigue or a decrease in physical fatigue from time 1 to time 3. I will now pass it over to Ali.
Thanks, Nat. All right, so this study here, we've actually got a couple studies that have looked at caffeine responses to, basically we're doing cognitive task performance about 2.5 hours. So what we do is we do a baseline assessment, give them caffeinated beverage. We've done caffeine, we've done cocoa, and what we find is that the responses are quite individualized. So this study here is currently under review, but what we've got is a randomized control crossover design where we gave people brewed caffeine. So do you know that there's a difference in the type of caffeine that you drink? All right, who here is a fan of 5-hour energy? Oh, we've got one person. Okay, so you've got synthetic caffeine, which would be found in, say, 5-hour energy, whereas you've got brewed caffeine or natural caffeine that's found in coffee. So as coffee drinkers, right, we're getting natural caffeine. And the other thing is also caffeine is usually infused with other ingredients. So if you look at that 5-hour energy bottle, the only person who drinks it, and those of you who don't, and if you look at other caffeinated brands, you'll see that there's things in it, right? So what we were interested in was, is there a difference in regular caffeine that you can find in 5-hour energy versus a brewed caffeine that was infused with adaptogens? And adaptogens are plant-based. And what we find is, if we look at it, look here, if we look at beverage type, there's really no significant difference, right? Then what we do is we look at their personality trait of energy and fatigue, and what we find is individuals who normally report being physically fatigued have better responses to natural caffeine than people who don't report being physically fatigued. However, if you look here, there's no difference in the control group. So you can see this here, right? There's really no difference. So what we're saying is there are certain people who respond better for fatigue to this synthetic caffeine. However, what we also found was there were no significant differences in feelings of energy. And if you want to talk about why you feel better after 5-hour energy, I'll be more than happy. You have my number, Andrea, so you can always text me. You don't, okay, great, yeah. So you don't always feel better with 5-hour energy. And we can talk about why there's that placebo effect. Turn it back over to Nat to talk about her study.
Yeah, so going back to the study where 27 participants participated in a community aquatic exercise program, they also had 2 or more pre-existing health conditions, including neurologic, orthopedic, cardiovascular, and endocrine. They completed a series of functional assessments, including the 6-minute walk test, 25-foot walk, and a 30-second sit to stand. They also completed trait, mental, and physical energy and fatigue. And what we found was that those who reported a higher trait of physical energy completed the 6-minute walk test the furthest and the 25-foot walk test the quickest compared to the others.
So, thank you. So this is not the only study. So this is our study. We had these people in for literally 48 weeks. We measured them every 12 weeks. And what we find is consistently physical energy is associated with gait-related outcomes. Now, Sprague and colleagues also looked at gait-related outcomes and feelings of energy and feelings of fatigue in the NHANES data set. And what they found was over the course of 10 years, energy was associated with functional declines as well as increased mortality and morbidity. So what that tells us is you need to try to decipher them as 2 different moods. Now, this is a study where what we did was we looked at gait characteristics associated with feelings of energy and fatigue, and what we find is there's basically, if you are feeling more physically fatigued, your stride length decreases, the number of steps in the turn decreases, whereas you look at energy and it influences different aspects of gait, right? By the way, am I loud enough? Am I good? Or do I need to hold on to this? I don't do well with holding on to things. Okay, great. I'll try. All right, so basically, as you can see, it's different aspects of gait. We'll talk about that in a little bit. But then look at balance. Balance conditions are different. So what we find is state level energy is associated with basically whenever you're standing with eyes open, feet on firm surface, as well as eyes open and when somatosensory input is unreliable, when you stand on a foam surface. But fatigue is only associated with eyes open, feet on the ground. So this is studies of 100, so this study was 126 participants. So these are large sample studies. And what we find is there's different aspects that they impact of gait and balance. So what we decided to do was, by the way, in 2017, I thought I was going to make my career. I wrote a paper that said, mental fatigue is going to lead to decreases in balance control and changes in gait. I was very wrong. And the reason why I was wrong is because I measured energy and fatigue as the opposite end of a unipolar continuum. What I said, bipolar continuum. So what I said was, if you're not energetic, then you're fatigued. Well, 31 studies since then have looked at that paper and said, oh, let's test it. What they found is half the studies found that there was a change, half of them found that there wasn't a change. Well, what we did was we went and we split energy and fatigue into 2 distinct unipolar moods, and we went, let's measure energy and fatigue. And what we find is, that, so I've only put the significant results and the fatigue stuff that's not significant, but what we find is declines in feelings of energy led to decrease in balance control. One of the cool things that we did with this is we used the Xbox Connect. Any Xbox players here? No. Oh, we've got a few. PlayStation. Oh, man. I don't know. We might not be friends after this. So, we used the Xbox Connect, which back in those days had an RGB camera, which is red, green, blue. So what it does is it gives you pixels. And so it tells you this is the shade of green mixed with the shade. So all of you know, right? You mix red, green, and blue, you can get different colors. Yep. I knew I should have paid attention when I was younger. Then I got older and I was like, oh, okay, so like all these pixels can mix together and form blue or form purple or whatever. So what we did was we looked at this and we were concerned with how is it that balance changes. And what we find is we were able to accurately identify with 74% accuracy when there was a decline in balance control using the Xbox Connect RGB cameras. So we've actually moved on from there now, and we're now using the LiDAR cameras, but we're also using iPhones. Hopefully, within the next couple of years, you'll be able to identify how someone feels using your iPhone. My fiance is she told me she's gonna be very mad if I'm like, honey, you're angry. She's like, I'll be even angrier if you do that to me. So, what do we know? How do we detect fatigue, right? So what we know is that there's unique biomarkers of energy and fatigue. Nathalie talked about the fact that dopamine levels change, serotonin levels change. We've got changes in peripheral mitochondrial function. We've got normalized metabolic rate. We've even got microbiome. How do we test all of those things with what we currently have? Right? If you think about the technology that we currently have, we've got smartwatches. Our smartwatches do have ways to detect SpO2, so we're looking at AVO2 differences, right? We can detect those. We've also got smartwatches, we've got sensors that can detect how we move. Now, as we start to put it together, what we want to do is we want to say, how can we best measure these? And what we find is there are some unique movements that are associated with energy and fatigue. So we had a paper, before I'd given this talk, the paper was still under review. So we present findings that have already been published about a week and a half, 2 weeks ago. So I'm going to go and show you a quick video. So what we did was we uploaded our sensor data to Unity, and we created these models. And let's see if you can go ahead and tell a difference in low energy and high energy. All right, so can anyone tell a difference? This is your naked eye, being able to see what we see with sensors. All right, now I'm going to go to high energy. By the way, this is on the study that we just recently published. So if you want to take a look at these models, you can always go to our study. And our study is in applied sciences. All right. So now we're looking at, oops, I don't know how okay. So now what we're doing is we're looking at low fatigue and high fatigue. Really tell a difference? You shouldn't be able to, because the naked eye, the changes are very subtle. Sorry, got to find my place. Okay. For a guy who works with computers, I'm not doing very well here. Okay. All right, so we find that the movements are different, but to you and I, in the naked eye, right, we couldn't find the difference. So what we have to do is we've got to use tech to the best of our abilities. Anyone know the difference, except for you all? No difference in machine learning, deep learning, AI. It all seems like it just melts. You read these fancy words and you're like, okay, cool. This is using this. It sounds really cool. So if I were to give you an explanation that was at a level that's very easy for you to conceptualize, what I would say is machine learning will use features. So for example, if I'm walking, right, I have gait speed, stride length, variances in my gait speed. I have toe off, I have toe out angle, right? So I've got all of these features that are involved in gait, how I turn, right? Those features would be used with machine learning. So we're extracting features and we're saying, hey, how do these features predict something else? We've got classifier and regressor models that we'll go into in a little bit, but basically what we want to do is, hey, we've extracted these features. Deep learning, on the other hand, is not extracting features and seeing what data are more important. So for example, if I was using these sensors, instead of saying, let me extract gait speed, stride length, all of those things, I'm going to see what part of that data is the most important to be able to identify it. AI, we're not at that smart AI right now. We can't. You know, I would love to say we'd have cars that can self-drive really soon. I don't know. I know someone else in this room also does this work, but we're not at that point where we can make decisions very quickly based on the data that we get. But basically, artificial intelligence would be, you know how our brain takes in information, makes a decision based on the information that we get? So AI would be taking in information, figuring out what's going on, and making a decision accordingly. So I think that's more like the surface level. So the steps to identifying feelings of energy and fatigue, what we did was we used a combination of classifier models and regressor models. Classifier models, what they do is they classify things. So let's say I'm going to take something that I think everyone they can conceptualize. You have certain people who are anxious at the moment, so you have certain people who are not. Can we classify someone who's anxious versus someone who's not? That's called a classifier, right? We're putting you in group. Regressor, on the other hand, is you're looking at it in a spectrum. So what we did was we used classifiers and regressors, and we classified our individuals into high versus low. And then we tried another model, which we just didn't have enough subject sample size. We had 126 people. We couldn't really do, were you high energy plus high fatigue or low energy plus high fatigue? We couldn't. I'll show you how terrible those models were. But it's good to, admit when you screw up, right? That's a big part of being an academic, is being less wrong the next time. Not necessarily being right, but being less wrong. So we also, first, before we did that, we only had 126 participants. When we extracted our features, we extracted over 130 features from our data. That's a lot of features. If anyone has run regressor models, right, or regressions, period, you know that's a lot of predictors. You've got to get rid of them. So we had to find the most important features. And then after that, we ran them through a series of different machine learning models, and we tried to identify the most accurate model. For our regressors, we identified the most important features, and then we identified the most accurate models after we identified those features. So when we looked at our groups, as you can see, there is no significant difference between our groups, right? Don't need to worry about this. You just know there's no difference. Now, let's look at the classifier and look and see how not only are the gait characteristics that are important different, but also the weight of them are different. So there's one that's the same, which is number 11 and 12. So if you look at number 11 for energy, is first step time in terms of anticipatory postural adjustment. So when you walk, you take a step forward, right? That's your postural adjustment as you're initiating gait. What we find is gait initiation is important for energy, but it's also important for fatigue. But look at the weights that are there. And then you see all these negatives on the very right. What that tells us is these features don't mean a darn thing. But the 4 features that we were able to get, those hopefully should help us identify those who fall in those different energy and fatigue categories. So what we find is our classification mean accuracy was approximately 0.743 or 74% accuracy. We were able to say these people are high energy, these people are low energy. And look at fatigue, 74.2, high fatigue, low fatigue. But then you look at the ones who are, when we started to split them up into high energy, high fatigue, low energy, high fatigue, right? Look at how much the classification accuracy drops. At that point, it's simply a coin flip. I don't know about you, but I don't want something to tell me 50% of the time that it's right. Right? How would you feel if, like, yeah, 50% of the time you'll get it? Not great, right? But when we went back and we looked at the features, it's because we just didn't have enough people. So if we had enough people, we might have been able to do this better. Talk about what's up next. And then what you'll see is for our regressor models. So the two things that we have in common here is 11 and 12 again. And what we find is that it's the imbalance in gait cycle time between legs as well as sex. Sex also ends up playing a role when you're talking about when you're treating energy and fatigue on a spectrum, rather than just saying high, low, right? When you're treating it on spectrum, you find that sex is also important. As Natalie said, women in general report feeling high fatigued. They also report feeling low energy. We don't know why. We have a study right now where we have collected this data, we haven't analyzed it, but we're thinking it might have to do with microaggressions that women face daily. We also think that maybe women are in general more expressive and ready to admit that they're not feeling well, whereas men are like, yeah, I'm good, right? Like beat your chest and be like, yeah, I'm good, nothing's wrong, I'm good. So we don't know if that's the case, but we know that sex is important. Now, when we're looking at these models, we had a couple of choices. We could have split up the models by sex, and if we would have done that, our accuracy rates would have dropped dramatically because we didn't have a large enough sample size. So we'll talk about why in a second. What we're doing next in a second. Now, I want you to take a look at the energy and fatigue. You've got bootstrap versus K-fold. So anytime you run a regression model, right, you get an R square. All of you familiar with that, right? You get an R square. Great. It's just for that sample. That's what that's telling you, is that for that sample, these are the variables that are important. These are the strengths at which they're important. So what you have to do is you have to validate your models. You've got a couple of options. With us, we chose bootstrap with one out, which meant we ran the model we had 126 participants. So we ran it 126 times, taking out a person after every time, right? So we took out a person, now 125, put that person back in, took them out, 125 again, right? We ran it over and over again. Look at the mean R squared on that, 0.884. However, our reviewers told us to also run a K-fold, which our sample size is not large enough for a K-fold. So look at how much they dropped with the K-fold. If I were to give you the basics of understanding of machine learning, and we were talking about regressors, I would look at R squares as the accuracy of your model. Whereas if you look at MAE right below, right, mean absolute error would be what's the error in those R squared. But look at how small those are. We think we're on to something here because our MAEs were really small, but then when we bootstrapped the way we should have, which is with an N of 126, you can't really do great K-fold modeling. So when we did that, look at how high our R squares were. So we've been able to fairly accurately identify feelings of energy and fatigue. And as of even a couple of days ago, these were the most accurate models out there. That means we're on to something. So what's next? We are currently in the process of using a combination of either deep learning or machine learning to identify changes in feelings of energy and fatigue over the course of a 30-minute walk. What we know is you feel better after you walk. There is an increase in feelings of energy at first, and then after feelings of energy have reached a certain peak, you start to see a change in feelings of fatigue. So you start to see a decline in feelings of fatigue, which means if we treat a 30-minute walk, you will see an increase in energy first and a decrease in fatigue afterwards. So we should be able to, hopefully, right? We'll see. We haven't run our models yet. We've only collected data right now as of yesterday on 18 individuals. Our sample size will be 26. We're doing 4 different interventions. Nat was actually responsible for setting that study up. She'll tell you that the student who recorded the interventions, we used interventions from behavioral economics instead of using it from pure XPhys perspective. And we have people doing, so we have people talking smack to our participants. So literally, you suck. Is this the fastest you can walk? Oh my God, my grandma walks faster than that. And then we have positive auditory cues, which are, good job, you've got this. We also allow for music of their choice, and then we've also got silence. And what we are doing is we're looking at walking gaits and seeing if we can identify increases in energy or decreases in fatigue. So it's a ton of data. We were actually meeting yesterday to clean it up, and we have large enough, right now we have enough data to be able to look at energy and fatigue and how it changes, but we don't have enough data to see if it changes between the different interventions. So we're going to continue, but until then, we're working on cleaning up our models. The other thing is metaverse, right? Everyone's heard of it, right? Facebook was just like, I'm just going to change my name. That's how I'm going to be cool with the young kids because TikTok is beating my butt. So I got to change my name. I got to be Meta now. Well, the whole thought of Meta is moving into virtual reality to do the tasks that we do. So we're working with actually Meta's exercise group to look at how doing exercise and how doing cognitive tasks in VR changes feelings of energy and fatigue. And then your Oculus that you wear has an accelerometer and a gyroscope. So we're trying to extract the data from the accelerometer and gyroscope and see whether we can predict the changes in feelings of energy and fatigue while they are wearing this Oculus. We're also trying to identify inter and intra-individual differences to these anti-fatiguing conditions. So one of the things that we find, as Nathalie showed earlier, is people respond differently. There's certain groups of people who are hyper, hypo, non-responders. We want to see if we can identify those. And so currently, we're using EMG and IMU sensors, but our lab right now is developing our own IMU and pressure sensors that we are going to be putting into shoes, belt, and then we're also going to go ahead and have it to where it can be sewn inside a t-shirt. They're about the thickness of a the white part of a Band-Aid. They're about the thickness of a white part of a Band-Aid, and they're about the length of a Band-Aid, and they have tiny microprocessors that can actually run one deep learning or machine learning model. And so that's what we're currently creating. The whole big picture is we want to be able to create AI that can identify those changes and prescribe interventions or even alert your provider. So we talked about declines in feelings of energy leading to increased risk for falls. We've also got increased risk for mortality, decreased functional outcomes. Right now, we're able to simply just get the data on a phone. We're only working with Android. So on an Android app, we're able to simply say, hey, decline in feelings of fatigue, decline in feelings of energy, or increase in feelings of fatigue. But the goal is to say, hey, X has happened to you, do Y now, to be able to modify those moods. And that's really the big picture of where this is headed. We're also using voice. Anyone familiar with the Amazon Halo? So Halo can detect depression and anxiety, 90-something% accuracy. We want to be there when it comes to fatigue, hopefully using a combination of smartwatches or, we don't know, or maybe it's our sensors. We don't know what's going to be the ideal way. There are some technological challenges because energy and fatigue are measured on a spectrum. When you're doing work that's on a spectrum, you need very large sample sizes. As you saw, when we tried to validate our models using K-fold, which is a better way to validate a model, it's not Bootstrap, is I don't know how to put this, but it's not as good of a way, right? So it's on a spectrum. We used a 20-point spectrum in our studies. The best measures that are out there right now on energy and fatigue are a 300-point spectrum. We didn't have enough people with 126 to measure on a 20-point spectrum. How many do you think we need for a 300-point spectrum, right? We'd need thousands and thousands of data points. So it's difficult to also create a ground truth, which means how are you at baseline? What are you at baseline? How do we get that, right? It's difficult when you're on a spectrum. It's not you're fatigued or you're not. It's on a spectrum. We have to find better signals. So that's where we're looking at pressure sensors as well. And then one of the other things that we're doing right now is we're working with a group out at University of Connecticut, the Corey Stringer Institute, and we are working with the biomarkers that they have to see if there's any sort of biomarkers that we might be able to say, hey, this is clearly what's going on, and we can use this particular sensor to identify it. So that's what we're working on, trying to find better signals and identifying feelings of energy and fatigue in more diverse populations. Most of the work that's been done has been done in very homogeneous populations. Natalie will tell you we are a primarily white university. I think, what are we, 87% white? Our sample is also representative of that. The other work that's been done has been done in Pakistanis only. Some of the work that we've been doing, so we actually, Natalie got a grant recently where she's using NeuroTrack eye tracking. And we're using eye tracking to be able to detect feelings of energy and fatigue. We tried to study with them in the past, and our models were just not able to capture changes in eye movement or change and how they associated with energy and fatigue in darker skinned individuals. So clearly there's a problem there, right? We've got these in a homogeneous population, and then what ends up happening is when you think about some of the AI models that are currently out there, and they're like, identify cooking, and all of a sudden this thing only identifies a woman because it associates it, right? And so that's a problem. We're working on Fairer AI. If you want to learn about that, there's a guy at University of Wisconsin who's doing some great work on Fairer AI and incorporating Fairer AI in your work. We're trying to do that, but that's not enough. We need more diverse data sets. We also are looking at multiple modalities, right? Is it maybe one's not good enough? Maybe we need multiple modalities, which is why we're doing the sensor IMU and pressure sensors. Also, creating real world technologies. So our current work is with 7 sensors. I don't know about you, but I don't want to wear 7 sensors every day, right? I want my smartwatch, maybe my cell phone, definitely, right? I can't walk around without my cell phone. Those 2 max is what I'm willing to deal with. Or maybe if I have something implanted in my shoe, belt, something that's already sewn into my shirt, yes, I might agree to that. But I'm not wearing one on my forehead. Can you imagine if I walked around here giving you this talk with a sensor on my forehead? You would all be like, who is this dude? Right? Why is he walking around with this? So we've got to find better ways. We've got to find real world technology. And then also, can we use signals from the omniverse and metaverse to identify them? I don't know, right? These are all questions that we need to ask, and we are trying to ask, and we're trying to do. We have a study coming up that starts this summer. We recently received a small foundation grant. We're going to be collecting this data on 500 individuals. We're going to have them come in twice because we don't want it's for us. We've been able to detect changes with interventions. We want to be able to detect it in what's called the outside world, right? Or you want to capture how they're feeling in the moment rather than, okay, we did this intervention, it did this, right? We want to be able to see how those spectrums change. So we're having these 500 people come in twice, and we're using a combination of IMU sensors that we've already validated. We're using LiDAR cameras, which are the new Xbox Connect LiDAR cameras. We're also using iPhones, and we're going to try out our new sensors to see if we're able to capture that data with our new sensors as well and see what works best, or maybe we use a combination of them. So we're currently so data collection can't start because we're currently setting up our neural networks. And as soon as they are set up, we will hopefully have everything ready to go. So that's kind of where we are to try to address those technological challenges. Are there any questions? Depends on what you use. So, for example, we primarily work with sensors that are lab-specific sensors. And so with that, it's been fairly simple when you're talking about, say, using the APDM mobility monitors. Not as simple with Delsis. We've tried using commercial technology. So, for example, we're currently extracting data from the IMU sensors that are found in your Oculus. That one's a very simple download. It downloads, we can feed that into our models. iWatch, not as much. Android-based watches, very easily. So it all depends on where we're getting the data from. Oh, Xbox and Xberries, they actually provide, now they provide it. Back when we were first doing it, they did not provide us with the software to collect data, so we actually created our own. And then what we did was we created it to where it was super easy for our students to just say, click record. And it recorded, and then once we had that, we were able to extract it because the RGB is able to plot joints, and then we were able to look at those joint movements and assess it that way. Yes. Sergi.
Thank you for your talk, Kelly. I think it's super interesting. And I really see here a tone of practical implications, to tell you the truth. You have here a huge marker of fatigue, right? So I have a quick question. You said that you are also utilizing EMG, right? So how are you utilizing EMG data here? What features from EMG are you utilizing?
So we're currently collecting EMG data. We haven't utilized it yet. But personally, I don't think it's going to work. But then again, so we're working with a group at the University of Georgia, and they were, because we're collecting it at Clarkson, but we were working with them, and they're like, EMG is the way to go, EMG signals. But all they do is they tell you muscular fatigue, right? They don't tell you overall fatigue. We think we might be able to actually extract how motor movement patterns change based on their changes in moods. But based on what I've seen with the raw data, we've simply just plotted each muscle, right? It's not consistent among subjects as well as over time. So I think that data is actually going to end up being pretty useless, but we're hoping to publish that and say, hey, those of you who are looking to do this work, don't go this route. Yeah. But that's kind of what we're seeing from simple visualizations.
Yeah, okay, that's cool. Again, I see for injury prevention, you can use this data for, never-ending things, design new biomarkers. I think this really can be very useful. Honestly.
Thank you. Yeah, that's what we're hoping. I think that's one of the biggest challenges is getting people to understand that they're two distinct moods. They can influence different things. So I didn't talk about this. One of the things that we see is when there's a decline in energy, we see increased errors in walking gait, which means there's increased risk for falls.
Exactly. That's the point.
Yeah. However, increases in fatigue, they start to be protective. So instead of making errors, they're like, okay, I'm just going to walk more carefully. So they're not at a higher risk for falls. They actually know that they have to slow down, right? But decreases in energy, they're now at a higher risk for falls. So for us to be able to classify that, I think is really awesome. And I do hope other people start listening and, start doing this, start using it.
Thank you. Thank you.
Thank you. Anything else? Oh.
Hey, Ali. Very good presentation. A lot of work, obviously, from you and your students. Thank you for being here. Ideally, how would you like to see this applied?
So,
in what context? Because it can go in many different ways.
So at the moment, we've been put in a basket with DoD. And those of you who've got DoD funding will know that basket doesn't really mean anything, right? It scored really well. Science was good. It's just that there were some issues or there wasn't enough funding for that work right now. So we're looking at DoD to identify potential injuries in, airmen, Navy, Army. And the other thing that we're also doing is we're going to NIH, NIA. So NIH, NIA, we actually scored really well. We were just above the pay line for that this year. But what we want to do is be able to use that data to determine when someone is going to fall and be able to alert them that, hey, you are now at a risk for falls. And then the other thing that we're able to do, which I didn't present here, is we're actually able to identify someone's long-standing predisposition to energy and fatigue, which is what's associated with functional declines and mortality. So we're able to identify that using walking gait, and we want to be able to alert providers and say, hey, Mr. Jones here looks like over the last 4 weeks has had a decline in energy. You should potentially schedule an appointment and figure out what's going on and maybe intervene. Right.
So you're thinking more older adults and military personnel for now?
For now, I mean, I think athletics would also be cool, but if you know of any places that fund the kind of money that's needed to do this work properly, that funds athletics, we would love to know, because we have not had success. It's a large dollar amount that it would take to do this sort of work. So yeah, we haven't found any place that's willing to invest that kind of money.
I understand.
Yeah, and we are in talks with the Joseph and Wu Tsai Foundation right now, but yeah, they got to also find the need for us to do it, right?
Thank you.
You're welcome. Yes.
Center's got a grant too. Oh, the UMass Life Sciences Center got a U grant for. They got a whole, sensor lab there, and they for machine learning approaches to sensors. They might be interested.
I'll definitely reach out to them. I was not familiar with them getting that grant, but I'll definitely reach out to them. Thank you.
Yeah, I can put you in touch if you like.
Okay. Thank you. Anything else? All right. Thank you.